Assalamualaikum warahmatullahi wabarakatuh. Salam, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. We from SA Vectura, project-based learning, charitable transporter. This is a project manager, and this my team. We can presentation the project.
And this is the problem statement. The problem of equipment works. The bottom state polytechnic wear over helmet by moving a large number of heavy tables and chairs. An effect is moving heavy furniture, such as table and chair requires effort and takes up a lot of workers' time. The impact is the work can cause fatigue or even seriously injury. A successful solution is a creating robot carrying chair and tables for a long time solution and improve the quality of life for humans. This is the system recruitment review. Identification need. The robot must be able to move table and chair. System requirement. Function. Non-function. Function robot can lift table and chair strongly, quickly, and efficiently. A specification is using a stepper motor DC, using a scissor lift with a lift capacity of up to 50 kilograms. And the success criteria is the successful robot. The robot can lift table and chair with an error of 5% in 10 tests. In is the concept design, in the aspect, need and problem formation, main component. The concept description is a student need to design a robot to be able to transport chair and table and be able to move freely in the room, in the auditorium. The main component is microcontroller, battery, acrylic frame, DC motor, buck converter. And is the system diagram, the power supply and battery to input, microcontroller to process, motor DC, motor servo to output. And is the mechanical concept, drawing by hand. And this is the program algorithm, concept design algorithm. One standby input from the on-off button to start the robot. The robot adjusts of initial position to be ready to pick up the object. The position is correct, first to step 4. If the position is not correct, return to step 2. The robot moves toward the object to be lifted. The robot lifts the object using the lift mechanics. The robot carries the object to the desired location. It has access to destination. Process to step 8. If has not reached the destination, return to step 6. The robot lowers the object to the desired location, and the program stops or waits for the next command.
Next, preliminary design including initial design, hardware selection, and program flowchart. All preliminary design aspects, from technical hardware to budget and risk, have been verified and approved, confirm the project is ready for the development and prototyping phase. Next, in here, the following is an image of the initial 3D design in isometric view. The design is designed from sense-aware and will be a new foundation in developing the trends. So we have a project budget of 400,000 in total part and price 27 and 308,000. Before moving to the final design, I like to explain our preliminary design first, including the initial 3D model, hardware components, hardware selection, and program flowchart. First, the robot is turned on and start the system initialization process. In this step, The ESP8266 motors and sensors are activated to make sure all components are ready to work. After that, the robot connects to Wi-Fi and the Blink application. If the connection fails, the robot will automatically reconnect until the connection is successful. Once the connection is successful, the robot enters standby mode and waits for command from the user. When a command receives, the robot treats and identifies the command type, whether it needs to lift a chair or a table. The robot activates the sensor lift mechanism to lift the object. If the object is not lifted properly, the lifting process will repeat until it is successful. After lifting the object, the robot starts navigating toward the destination. If it has not reached the destination yet, it will continue moving. When the robot arrives at the destination, it lowers the chair or table. Next, the robot checks whether the task is complete. If the process is not complete, it will repeat the step again. Finally, the robot checks if there are any new command. If there is a new command, it will process it again. If there are no new command, the robot returns to standby mode and waits for the next instruction. So overall, these posters show that the robot can work continuously and automatically based on user command. These slides show the critical design review for our robot project. First, for technical specification, all components are already in accordance with our plan design. For electric design, the microcontroller, limit switch sensor, and actuator have been in field test. For electronic design, the microcontrollers, sensor, and actuator have already been tested. For sensor selection, we use limit switch sensor because they provide for response and good accuracy. Then our PID algorithm is already compatible with the robot system. In terms of speed or availability, the robot can still move properly uses the Blink application through Wi-Fi. For power consumption, the battery usage is efficient enough for operation. Also, the mechanical design is strong enough to lift chair and table. However, the lifter mechanism still needs improvement because it is not fully optimal yet. And of overall system testing, we still need more testing in different conditions. Finally, our technical documentation has been complete. So overall, most part of our robot are ready, but there are still some improvement needed. After refining the system design, now I would like to show our final 3D design, config hardware selections of our algorithm. This is the final design of our chair and table transporter robot.
This is a confirm hardware selection in a robot chair and table transporter, and um, I can do how work the component electrical in a robot, and this we can for battery uh, to stay connected and output for battery to connect in step down for output step down for the for output step down become the fault to join connected to in the for driver motor and connected to input step down and output step down to step 4 for become 5 volt to connected to for input in MCU, and we have and we ask to microcontroller because of I because of the slot in I/O pin MCU, and this is to yellow gearbox motor DC for a mobiling robot forward, reverse, and left and right the robot. And this is two DC two two motor DC for up and down is lifter scissor lifter, and this is um, limit for up and down to lifter, and a trigger for because like a robot up up or pick up pick or up object.
Draft and final design. This is our first draft and final design, which is the new finalized version ready for production of prototype. This one is expert drawing. You can see each part is located different, lower or higher, so you can see the assembly process. And this is the final assembly of and this is our final assembly with the dimension on like above the ground. It has 288 of a liter, and between the liter is 150 105, and long the length of our robot is 210, and the width is 155. And this is our schematic environment data, which is it has been explained by my friend before. This is our project timeline, budget track, and resource management. In the project timeline, week one, we doing problem identification and concept design. Week two, analysis of components, circuit structure and symbol control system. And week three, we do analysis of component, circuit structure and control system. And week four, mechanical and problem development. Week five, electrical diagram and schematic wiring control system. And the last week is week six, and Purba and presentations. This is our budget plan. Uh, the part and component name like pro controller, customer view, lithium battery, bearing, breadboard, motor DC, motor driver, limit switch, hollow battery. I will be cable, like really sheet alpha, and the total part and price is 400,000 rupiah, which was exactly project budget we get for this project. And the last one is research management. The resource management is including project test, effort base, resource type, and deliverable. Like project management, it needs effort test of D2, concept type, concept it to have that 2 days, analysis in 5 days, design in 25 days, and simulation in 10 days. The last one is conclusion. Sure, thermal transporter robot was invented by Batam Polytechnic student, which is really me and my friend. Student to make it easier for staff and officer to carry out their duties. For example, when the table and chair are moved into room like auditorium, when there is a bot, like when there is a robot will help with the heat below. where the worker only need to be operator and this robot will move according to the instruction when the remote control is operated. The robot will move the table and chair following the instruction from the operator directly. And with this, the robot it will increase efficiency in work and reduce the workload of officers such as the risk of injury and the risk of damage of the material being lifted. Okay, that's all of the reason of our mid semester benchmark presentation. We apologize if there are any error in reading or writing this report and presentation. We excuse ourselves. See you at the end of the semester benchmark. Thank you. Assalamualaikum warahmatullahi wabarakatuh.